All right. Well, good evening, everyone, and welcome again to Environmental Coffee House. I am Sandy Shellis, and this is my partner, Jennifer Hines. Welcome, Jennifer.
Hey, Sandy. Hey, everybody. We have a fabulous show for you today. It's all about Ice Ice Baby. It's that time of year. It's about that
Yeah.
time of year, Sandy. We're getting into September, which is the
Yep.
Arctic sea ice minimum. So we generally focus a lot on ice and find out what's happening. So let me tell you guys what is up tonight. So the first one we have is from Axios, melt records set in rapidly warming Svalbard and Norway. So that is where the hot spot is right now. It's Svalbard and Norway, all up there. And then we're going to do a little tweeting research, right? A little
Oh,
tweet.
yeah, yeah. We'll do a little Twitter. Yep.
Yeah. And then we
Absolutely.
have our next one from Explorers Web, NASA record fastest melt ever in Svalbard. So we can sort of notice a trend there, right?
Mm-hmm.
Then we're going to go over to the Washington Post and
Yeah.
the article. Yeah. And it is
Wapo.
WAPO.
Wapo. That's the Washington
WAPO.
Post.
WAPO. 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 WAPO.
There you go, Jen. Okay, where's the cats? We're the only doomer pussies around. There you go. Wow.
All right, all right, all right. Climate change's impact intensifies as U.S. prepares to take action. So, you know, better late than never, I guess.
Yeah.
And then we're going to go over to CBS News. Zombie ice from Greenland will raise sea level 10 inches, study warns. Well, I've got a few
Lovely.
things to say about this. Um,
Can't wait.
yeah. And then we have an article from nature.com, Nature Climate Change, Greenland ice sheet, climate disequilibriation. Okay, disequilibrium and committed sea level rise. So we're not actually going to go through this whole thing. This is a scholarly paper
Oh,
in
it's just what the other
nature.com.
article. Yeah. It's what
But
everybody else is taking.
what's interesting is who wrote it, right? If you look at it, it's
Yeah.
like a bunch of luminaries. Jason Box was the lead author. And then a name that we're finding these days, Xavier Fetwis. Apparently he's a new luminary. Did you know? And
No?
then there's other people. Oh, Xavier Fetwis, I think he is. I think he's been tweeting a lot. And then we're going to finish up with an article from the Financial Times, Methane Hunters.
Yeah.
What
Methane hunters.
explains the surge in the potent greenhouse gas? So
Yep.
deep dive, guys, into methane.
And
So
we have an
that,
intermission, of course. We have an
oh,
intermission,
yes.
of course.
Oh, good,
Oh,
good, good.
yes. Before we
Good, good,
read
good.
WAPO, we will be playing our intermission. I
Okay,
think we're going to
good.
do that. Yeah. So good evening, everyone. Joaquil and Patty, Kim, thank you. And Jean and Gary, Rich, Diana, thank you, Kim, for moderating, and Scott. And
Hmm.
this is great. Foggy and Jean and trans women are sexist men. And Kim's. Okay. I think I got everybody. I think I've got
That's
the
great.
names down, Pat. Let's go. We have a busy show.
We
So
do
we'll
have a
go to
busy
the
show.
first article and take it
Yeah.
away. Take it away.
Okay. So this first one up, guys, this is from Axios, melt records set in rapidly warming Svalbard and Norway. Amazing graphics with this. The Norwegian Arctic archipelago of Svalbard, situated northeast of Greenland, is seeing a record melt season tied to human-caused global warming. Scientists tell Axios why it matters. The meltwater is pouring into the Atlantic Ocean, where it helps to raise sea levels. The rapid melt this year demonstrates Svalbard's status as one of the fastest warming places in the Northern Hemisphere at about 3 times the
Mm.
rate of the lower altitudes.
Wow.
Zoom in. According to Xavier Fetwis, what did I tell you? Xavier Fetwis, listen for that name, guys. A geography professor at the University of Liège, the mean meltwater runoff is 42.6 billion metric tons in 2022, which is 3.5 times larger than average and 1.4 times larger than the previous record set in 2018. So
Jennifer,
melt.
I thought that ran off my roof today
Holy
in
cow.
rainwater.
I was just randomly looking at the weather satellite, and I saw a big ball of water over in Sandy's neck of the woods.
It was.
Big
Oh
ball
my
of
God.
yellow and red zone water, and I'm like,
Yeah.
"Holy cow, let's check
Dirty
this out."
rainwater.
And
Yeah. And I was
I finally
outside.
found Angelica, and I zoomed in, and I'm like, "Holy cow, Sandy's getting creamed over there. It's absolutely
Creamed.
pouring." So I
Creamed.
she's getting creamed, right? Remember when we used to say that when we were kids?
Yes. Yes.
That's
Oh,
right.
yes, it
That's
was.
right.
Creamed. Like it
That's
was
right.
throwing a cream pie in your face.
Well, whatever it is, I sent you a text. I'm like, is it absolutely pouring at your house? And she
Yeah.
wrote back. She said,
And
yes,
I had
it
to run
is.
out at least 4 times
She
because
sent me a bunch
I
of videos.
yeah, I haven't set
Yeah.
up the relief valve for the gigantic water tank. And
Not
that's all set up.
gigantic anymore.
No,
It filled up in 10
278.
minutes.
Oh my God, Jennifer, unreal, unreal. So there's more to make this thing work. I have an overflow tank, and then we're going to
Yeah.
have an overflow valve. The thing is, you get a goddamn drought for 2 months, no rain, like a little
And then it
trickle or
just
and then
pours
it's
and pours and
pours.
pours.
It's not even like every gutter, all the soffits, everything is not right, and it can't handle the
Mm-mm.
torrential rain. It is torrential. It is monsoon. It goes every
Yeah.
which way. I filmed it going every
Yeah.
which way, and I realized I had better get my ass in the house last night, or I'd be like, fried, because it was also an electrical storm. So today
Indeed.
yeah. So there's the hat, because I've been in and out again 3 times. I got soaking wet. All right. Well, anyway,
Hats
let's
are great.
continue.
And it's the
Yes.
WASF hat as
Oh,
well,
yes.
I
Oh,
believe.
yes, Jennifer. Yours
Yeah.
is coming.
Oh, good, good. I'm happy about
Woohoo.
that.
Yep.
All right. Back to business. Back to
Back to
business.
business.
Svalbard set a record on July 17th for its highest recorded melt volume, according to the National Snow and Ice Data Center. This was due to a push of relatively mild air well north of Scandinavia, and it was related to a melt pulse in northern Greenland as well. So that entire area, northern Greenland, Norway, Svalbard, the whole thing is under some sort of heat dome. Fetwise said the meltwater runoff anomaly is 5 times the variability from year to year during the 1981 to 2010 period, which he says is statistically unlikely. Only a changing climate can explain this, he said via email. So, the context. Unlike glaciers that terminate in floating ice shelves, most glaciers in Svalbard don't melt at the base and instead do so from the top down. An early snowmelt from this year helped to prime ice surfaces for melting, Ted Scapos of the University of Colorado at Boulder told Axios in an email. According to Scambos, temperatures in Svalbard have been about 2 to 3 degrees above average since May, which is an unusually long stretch of time. May took away much of the fresh snow, exposing the glacier ice and older snow to warm air and sunlight easier in the season than is usual. Scambo said this has in turn allowed for more rapid ice loss. Fetwise pointed to the suspended sediment in waters near Svalbard seen in the satellite photos as an indication that the melting is now occurring at the base of the glaciers. So, whoa, right?
Whoa.
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 This this could increase the discharge of icebergs in the next years, accelerating the mass loss from Svalbard due to global warming. I said, yes, but while the melting of Greenland's ice sheet is the largest annual contributor to sea level rise, the melt seen in Svalbard this year is yet another warning sign of the consequences of a rapidly warming climate. While it won't cause an immediate obvious increase in sea levels, any added freshwater contribution to the ocean from Svalbard or other land-based ice helps worsen growing damages from sea level rise, of course. This includes the phenomena of increasingly frequent tidal flooding, also known as sunny day flooding, like they have in Miami, right? Which the National Oceanic and Atmospheric Administration warned is an increasingly prevalent phenomena along the U.S. coast.
On
So
Tuesday.
there,
Yep.
I didn't know Gorbachev died. That was like the next article in,
He did.
Did
I
you know?
saw that. I saw it today. Yeah,
Oh,
he was
wow.
like 91 years old. History
Wow.
died. Russian history died today.
Oh, wow.
Yes,
How
it
about
did.
that? Big
Yes,
change, big
it
change.
did. Well, I thought what I would do is show this picture
Mhm.
for the Belgian Earth observation. And I just want to say one thing to the chat. I don't know what's going on. I think that we are probably not understanding any of it that's going on. Just everybody get along and let's enjoy the show because it's tough stuff. It's not exactly enjoy. So we're going to look at Svalbard archipelago and look at the in the left side. And Jennifer, see, and the change. Can you imagine it's
Yeah,
going to keep going like that?
I know.
It's
I know.
and that's the it's horribly sad, horribly
Yes.
sad. So there's
Yes.
a bigger look, and it is the research of today. It is what's in what's
Wow.
cooking.
Wow.
Oh my
Okay, so
God.
Sandy, me and my imagination, Svalbard to me looks like a dying elephant. Do you see it? Okay, so
Yes,
there
there's
here,
the
the
eye.
trunk is
See the
coming
eye, and
down.
there's the
Yes,
trunk.
yes, yes,
Oh
it looks like a
my God,
dying elephant in
Jennifer.
the desert.
Boom. The dying elephant. She got it. There. Horrifying. Look at
Oh, it
it.
is
Oh
horrifying.
my
It looks just like an
God.
elephant.
Oh, it does. And
Mhm.
and a dying one. Well, Earl says 830,000 livestock lost because stop. You know what? Everywhere where it's horrible, just stop breeding animals. Stop. Stop breeding animals. All right, we're going to move on because I just wanted to show that picture. Now, NASA
Mhm.
has done the same thing. And they are
Yeah.
also, everybody is, jumping on the Svalbard is screwed train, kind of. The
Yes.
fastest melt, and they have different pictures. They have satellite, that it's retreating sucking sound. So it's also the same thing, basically, same climatologist, same article. This one exactly talked about. It was a lot of University of Colorado at Boulder, Jennifer. You know that. Everybody's
Well,
from
I've been
Boulder.
telling you. I've been
It's a
telling
great
you.
school. You are just in, yeah, it's a great school. It is the climatological school. But really,
Boulder in
seriously,
general, there's so much stuff going on there, huh?
good place. Good
Yeah.
place, huh? So this is the light blue areas where the snow and fern have melted away, exposing bare ice. Clearly marked melt ponds indicate the softest spots on the ice. Oh, that's look at that. See, in Svalbard. It's
Mm,
like you
mm,
get scared, like you
mm,
look at it
mm,
and you think, "Oh, I could just walk right through it."
mm,
And the
mm.
mountains, they were talking about in the Himalaya, they noticed similar changes in the Kakaram,
Right,
and
right.
it's it's just it's happening, guys. It's happening. It's happening. But we will bring you this because everybody's talking this week, and we did already about Pakistan, which is one third covered with water. I mean, it
Unbelievable.
is insane. Yeah, and I bitch about the
Those little
front.
videos you showed last, when did we do our last
Friday
show? It
night
was
we were
recently.
together.
Oh my god.
Friday night we were together.
That's right. And that
Yeah.
video you showed about, the houses washing away in Pakistan. Oh my god, it was
It
horrible.
was awful. It really was. So here we have Zach, who is one of our favorites. The summer has observed a historic melt, and Jennifer, if you wanna, this is Xavier Fetweiss. I think he's destined
I
to be
told
on this
you
show.
it's
I
all
think
about
he's
Xavier
yeah.
Fetweiss.
I
It
think he's
really
gonna
is.
have to be a guest. I really
Right.
do.
I think
Why
that
don't
that
you?
has to do with the surface mass balance index. And I think it's just crumbling away, but I have to remember it because unless I can pull that tweet up real quick, because I cannot possibly read it at all. So let me see if I can just grab it because I did send it. And here it is, Xavier Fetweiss. Okay, so this tweet from Xavier Fetweiss, I like saying that name.
Okay, we
Um,
have to find the
this
guy.
is, I know. I wonder what nationality he is. The current
I think he's German.
2021 is he?
Yeah.
2022 surface mass balance, SMB.
Oh.
So what does that mean? Well, surface mass balance, what that means when something sinks like this, look at 2022. The surface mass balance on Svalbard has destabilized. What this means is that Svalbard is melting away before our very eyes. So the surface mass balance anomaly over Svalbard is incredible, close to 2 times larger than the previous record, 4 times larger than the 1981 to 2010 interannual variability, out of any statistically likely anomaly without global warming. So this is the
Mm-mm-mm.
cumulated SMDB, surface
We
mass
are.
balance. And the balance, we are out of balance. We are out of balance. And this is absolutely clear. Right now, we have crossed over the tipping point, and you can just see we're tumbling in Svalbard. The surface mass balance is gone. It's going way, way down. Boom, just crashing. So, Sandy, did you ever see the movie that came out in the 80s, maybe? Koyaanisqatsi? Do you remember that movie that came out in the 80s? Do any of you out there remember Koyaanisqatsi? It
Anybody
was
out
a
there that's
it
paying
was it's
attention?
it's an Indian word in some language which I don't know, forgive me, and it means out of balance. And
Oh.
it was a movie that came out, I think around, if I recall, about 1980, maybe 1984 or 5. Somebody can check and look it up. But Koyaanisqatsi was just a very visually rich movie of a bunch of stuff really
My
speeded
gosh,
up,
what's going
like
on out there?
thousands of people in New York going over crosswalks and everything. It was just like, and then it had some crazy music. But anyway, this picture here reminds me of Koyaanisqatsi. Maybe somebody remembers that movie back in the day.
Hmm.
So that's what that is. It's basically we're out of balance and we're crashing right here, right now. The surface mass balance is crashing in Svalbard. That's what that
Wow.
means. Yeah.
It's a it's a very difficult time.
It is. No, it's happening
Yeah.
right now. I mean, finally, we all been looking at this for decades, right? Everybody here on this show, probably, we're
Yeah.
all people of a certain age.
And then people have to fight over the most stuff that should never be fought over. Okay,
Yeah.
well, I'm going to go into the Washington Post. And
Yes.
do you think we should show the video, our
Well, I
intermission
can
first or
tell.
after?
Oh, it's up to you entirely, but there was a video in one of these articles. I thought it was in the Washington Post,
Oh,
but it's too long to show. I don't even. I think I may have lost it now, but
not the
I saw
Biden
about.
one.
No.
No.
Oh, no, here it is. It's
Yeah.
in the zombie ice. Okay, it's
Oh
in the
yeah,
zombie
that one. I
ice.
think I saw that one.
I
Sure.
had some
Okay.
comments
Well,
about that, so.
I think we could start. Um, you know what? Let's take a break. I'm going to show you guys my
Okay.
video. I want you all in the audience there to just love one another and accept one another. Because whatever's happening out there, it's hurting my feelings. And this is Jennifer and my show.
Do we have
And we don't.
do we have a
No,
bad chat going
no,
on?
there's some misunderstanding, and I think I'm hip to it. That's all. And I love
My
everyone, and I want to love everyone. So, okay, so we have a really kick-ass intermission here, guys. You are definitely going to enjoy it. So I am going to set it up, and here we go.
My name is Janet Intreri. I'm a research scientist at NOAA in Boulder, Colorado.
Why is Arctic ice melting?
Sea ice is basically just frozen seawater. As the year goes on, you get a lot of sea ice that forms in the winter, and then it often melts in the summer. Some sea ice stays there even through the summer, and that is what we're seeing is shrinking, is the ice that should be there all year long. So even though the ice melts and grows and actually even moves around with the winds and the ocean currents, we still see that all of that sea ice is getting less and less each year when we look at it with our satellites. We know that the sea ice is melting every year more and more. And we know that because we have satellite pictures that we can see each year, and we compare that to know that the sea ice is shrinking more than it did even the year before and the year before that. So over the last 30 years, we've been able to see that the ice is getting smaller and smaller at the North Pole. We also know that the temperatures are increasing, and we have measurements from all over the world that tell us that. And I think we all are scientists at heart, because we know that with warmer temperatures, you melt ice. So when you take those two things together, we have a record of understanding. The ice is getting smaller. We know that the temperatures are getting warmer, and we're able to know all of this through our satellite and measurement observations that we have all over the world. Even though none of us live at the North Pole, we care that the sea ice is declining every year for many different reasons. One of them is that the sea ice is a habitat for seals and polar bears, and they need the sea ice when they are hunting or fishing for their food, and for raising even their young polar bear cubs or their young seal pups. We need to watch what the sea ice is doing, because it matters for even the rest of the planet, and how the currents of the ocean move, and how the temperatures of the atmosphere behave. And we can feel that down here where we live, and that's why we monitor it to understand how it's changing in the future. Because if we lose a lot of sea ice, it does affect a lot of these other things.
I don't think climate change affects anything. It's how Mother Nature just brings climate to us.
The hurricanes are much worse. There's got to be some reason.
Do you believe in climate change?
No.
Why not?
Bullshit.
What do you mean, Elvis?
Climate goes up and down for centuries and millennium. There's no such thing as climate change.
They know they have problems.
In
They
one
know it's not
session,
a
we
fact.
witnessed attendees trying to discredit the work of the International Panel on Climate Change, the IPCC.
They know they're lying.
They're assuming what they're supposed to be proving.
Where were the climate attribution studies for the 17-year hurricane drought?
Last question.
And when you're talking about IPCC reports, You know, they're not signed off by a couple of people, it's hundreds of scientists in the world, and the wording for those reports is agreed by almost every country in the world. Granted, you don't all agree with that, but if you don't, how do you account for the increasing severity of forest fires, of droughts, of floods that we're seeing in the world? You're all having a good laugh, but how do you account for these things?
You need to be very precise in what you are alleging.
Guess what we've seen this year? But they're not keen on an alternative view, as I quickly discovered.
You can't measure what's happening in global warming and what happened this year.
That's totally fake science.
What's wrong with more warming?
Mysterious sinkholes, openings in the permafrost, Arctic soils that have, until recently, been permanently frozen to great depths. The mysterious openings were unlike any other features previously observed in the Arctic, emitting high levels of methane, a potent greenhouse gas. Evidence from the surrounding area indicated the craters were formed after a significant buildup of subsurface methane, apparently ignited in an explosive blast.
And now you see the mysterious interior of the crater. A camera hanging on a rope passes down the frozen walls. And finally, near the very bottom, at the depth about 70 meters from the surface, there is a crack. We believe that this was a probable pathway for methane release from natural gas storage reservoir. Here it is. The crater features are unstable. Already in a month it was half filled with water and thawed sediment. Next year it was already a lake, increasing in area every year in a row. All known gas emission craters are now lakes and can hardly be identified among other numerous tundra lakes.
Science is clear that man-made emissions of air pollution and global warming gases are changing
global warming
our
is still an
atmosphere.
issue that the scientists are still debating, and you know it and I know it.
On the causes of climate change are far from settled.
Well, the climate's always changing. That's not the fundamental question. The fundamental question is whether man-made activity is what's contributing most to it. I understand that people say there's a significant scientific consensus on that issue, but I've actually seen reasonable debate on that principle.
You look at this last year, it was the warmest year in the last decade, I think was the numbers that came out. I accept that. I do not say that it is man-made.
I don't think CO2 is a problem, and therefore I don't think it needs to be regulated.
We all breathe CO2, climate changes, but there's no evidence at all that it's man-made CO2 that causes the climate to change.
It's almost comical. Every time we exhale carbon dioxide. Every cow in the world, when they do what they do, you've got more carbon dioxide.
It could be secular. It could be just a shift on the axis.
The ice caps are melting, which we see over and over again. Yeah, they're melting on Mars too.
I'd like to have somebody look at the lesser optimum, which is a little closer in time, and how much did the temperature rise then. We know that led to the Vikings dominating Europe for several hundred years.
The idea of human-induced global climate change is one of the greatest hoaxes perpetrated out of the scientific community. It is a hoax.
Is it the end of the world as we know it, or just a hacker's hoax?
Orange County cable customers heard the ominous prediction on the air today that the world is going to end Saturday.
What are you guys doing on Saturday?
Yeah.
What are you all doing on Saturday? Is that ominous or what?
It is. That was. And they're so, well, people can't be that stupid. It's willful ignorance because it doesn't fit into what they want. It destroys whatever's in their desires.
You know, if you noticed the moron brigade of right-wing idiots, all they do is they swap them out for another one. And so the current, what do they call them? The current cackle of, or gaggle, whatever it is, the word of idiots in the Congress that also still, I mean, Marco Rubio's still there. They still talk about it. These people are just, they'll be the death of us. They'll be the extinction of us.
They're just so stupid. I get so impatient. And it's so easy to figure out if you
this
would
is
just
2011.
take a look. It is not being debated by scientists. These are just
No, and
amazing.
that's what 2011. It is not. That's 11 years ago, and it's the same people talking the same shit, same shit. So listen, I want to ask you. Maybe we skip, in the interest of time, the WAPO and go into the zombie article. I think it would be. I think we're going to skip WAPO this time, guys. I think we have some dig in time with the fun stuff. So why don't we do that? Jennifer, why don't you take this one? And then do you want me to play this video first? Because it actually, I'm sure that they can hear it.
Yes, please play it. And it's
let me make
10
sure,
minutes, just to let you know. It's a
yeah,
10-minute
but you know,
video.
so what? It's video night.
It's fine. Yeah, exactly.
So what?
Play
Yeah, it
Yeah,
was
it's
good. It was good. Just make sure, everybody, you tell me if you can hear it. I mean, because you know, you never know.
That the Greenland ice
They
sheet
should be
is
able
set
to hear it.
lose 3.3%
System audio
of its
is on.
mass. That's equal to 110 trillion tons of ice.
I don't know if I can
The
make it
findings in
bigger.
the journal Nature Climate Change say this will trigger nearly a foot of global sea level rise. The study did not specify when this will happen, but researchers predict much of it can play out between now and the year 2100. For more on this, I want to bring in Ted Scambos. He's a senior research scientist at the University of Colorado in Boulder. Ted, let's kind of try to bring these numbers down into sort of more manageable form. We've known that the ice sheet has been melting. Is this a case of it's melting even faster than we thought?
No, this is more a case of recognizing just how much we're committed to, even with climate staying right where it is. What the study did was take the last 20 years, where we have really good data, both from satellites and from weather systems, weather instruments, and looked at how Greenland has lost ice from year to year, given warmer years and cooler years. If the next 20 years are an example of what climate in Greenland is going to be like over the next few centuries, then we're in for an ice sheet that's going to shrink to the extent of about a foot of sea level rise.
And what does that mean? What would that cause? What would happen?
Yeah, it has more impact the further south you go because of the way the water gets distributed over the surface of the ocean. It's not just like filling up a bathtub. There's places that fare worse than others. And in fact, the southern coasts of, the United States, around Asia, the tropical belt, those areas see a little bit more sea level rise as time goes forward. What it means is that we're going to see additional sea level rise over and above what we're seeing year to year now as Greenland adjusts to the new climate. And that's assuming that climate doesn't get any warmer, which almost everybody assures that it will.
And let's focus on that for a moment. What causes the sea level rise? And what's your assessment of whether that will get worse or better?
So Greenland is a large mass of ice. It was formed back when the Earth was a lot cooler. It's been through some ups and downs over the past several thousand years, but now we've begun to really push on this warming trend, and it's through greenhouse gases that have been added to the atmosphere. The perimeter of the ice sheet is melting more than it used to. You can see a large band of blue ice, that's deep, high-pressure ice, that's beginning to erode or melt away off the sides of the continent. And the glaciers are all, especially in southern Greenland, flowing faster than they used to. And so we're seeing both faster flow and runoff in the form of water contributing to sea level rise. That's sort of going to play out for the next several centuries, a lot of it this century, and that's what the study is pointing out.
And so is that what the time frame we're talking about here is over several centuries, or is that the right time frame we should be thinking about if anybody hears about this and is alarmed and wants to take action?
Yeah, so the ice sheet is finding itself in a climate, an environment that it's not stable with. It has to shrink somewhat in order to have a stable size that remains constant from decade to decade. Right now, there's parts of it that are sticking out at low elevation and further south that need to melt away. So a lot of this is going to happen in this century, but it's going to play out over a very long time. Now, the thing that the study didn't mention is that climate, as I said before, is almost certainly going to get warmer. So we're going to keep stepping on this accelerator pedal for ice loss and sea level rise through this century. And you can say it's impossible to stop it. The way to stop it would be to go to a climate that's actually a little cooler than it is today. And that's very far in the future with a whole lot of work for the human race before we get there.
What planet is that?
If the climate gets cooler, that just slows the rate of loss, right? There's not a chance that there's going to be any accumulation of ice.
That's correct. It would take a very long time before the ice sheet were to regrow geologic spans of time. It's basically up to us to start tapping on the brakes and get this under control. And I have to say, I'm pleased with some of the things that have been passed by Congress recently. I think we've taken some big steps in the right direction.
All right, Ted Scambos, thanks so much for helping us understand this.
Sure, thank you.
Turning to politics.
Is that 3.3% of the Greenland ice sheet is melting, and it's going to cause 10 inches of sea level rise. So all told, there is 28 feet of sea level rise wrapped up in Greenland. So, how fast is it going to happen? I don't know, but he says 3.3% of the Greenland ice is letting go right now due to zombie ice. So let's talk about this zombie ice. Can I take it away, Sandy?
Take it away, Jennifer. Take it away, baby.
Take it away, baby. Okay, so this came out in CBS News. That's what we're on right now. Zombie ice from Greenland will raise sea level 10 inches, study warns. Zombie ice from the massive Greenland ice sheet will eventually raise global sea level by at least 10 inches. I can't believe how careful and conservative this article is. Maybe you guys notice it too, right? Which is 27 centimeters on its own, according to a study released Monday. Zombie or doomed ice. Okay, so doomed ice. That's interesting. Doomed ice is ice that is still attached to thicker areas of ice, but no longer getting fed by those larger glaciers. That's because the parent glaciers are getting less replenishing snow. Meanwhile, the doomed ice is melting from climate change, said study co-author William Colgan, a glaciologist at the Geological Survey of Denmark and Greenland. It's dead ice. It's just going to melt and disappear from the ice sheet, Colgan said in an interview. This ice has been consigned to the ocean, regardless of what climate emission scenario we take now. Study lead author Jason Box, glaciologist at the Greenland Survey, said it's more like 1 foot in the grave. I love Jason Box and his realism, right?
Yeah.
Yeah. The unavoidable 10 inches in the study is more than twice as much sea level as scientists had previously expected. See the trend from the melting Greenland's ice sheet. The study in the journal Nature Climate Change said it could reach as much as 30 inches. By contrast, last year's Intergovernmental Panel on Climate Change report projected a range of 2 to 5 inches for likely sea level rise from Greenland by the year 2100. You know. Enough said there. So conservative, right? What scientists did for the study was look at the ice imbalance. See, this is the thing we're talking about, the ice imbalance. In perfect equilibrium, snowfall in the mountains in Greenland flows down and recharges and thickens the sides of the glaciers, balancing out what's melting on the edges. But the last few decades, there's less replenishment and more melting, creating imbalance. Study authors looked at the ratio of what's being added to what's being lost and calculated that 3.3% of Greenland's total ice volume will melt no matter what happens with the world, cutting carbon pollution, and that's truth. I think starving would be a good phrase for what's happening to the ice, Colgan said. One of the study authors said that more than 120 trillion tons, 110 trillion metric tons of ice is already doomed. So that's how much ice is doomed to melt. Doomed to melt from the warming ice sheet's inability to replenish its edges. When that ice melts into the water, if it were connected only over the United States, it would be 37 feet tall. Deep. It would be 37 feet deep. Excuse me. But that's kind of the same thing.
Yeah, it is.
Okay, so
37
that's
feet.
wild. So, okay, like I digested it. So take the United States. Let's just take the local landmass, not Alaska and Hawaii, and then put 37 feet on top of the map of the United States.
Right.
That
we'd be underwater.
37 feet is the amount of doomed ice that's gonna...
Holy shit. That's pretty heavy.
It's a lot. It's a lot. But if you average it out over the entire globe, it's 10 inches instead of 37 feet. But it's always good. The visuals are good. This is the first time scientists calculated a minimum ice loss and accompanying sea level rise for Greenland, one of the year's two massive ice sheets that are slowly shrinking because of climate change from burning coal, oil, and natural gas. Scientists used an accepted technique for calculating minimum committed ice loss, the one used on mountain glaciers for the entire giant frozen island. Pennsylvania State University glaciologist Richard Alley, who wasn't part of the study but said it made sense, said the committed melting and sea level rise is an ice cube put in a cup of hot tea in a warm room. Quote, "You have committed mass loss from ice," Ali said in an email. In the same way, most of the world's mountain glaciers and the edges of Greenland would continue losing mass if temperatures were stabilized at modern levels because they have been put into warmer air, just as your ice cube was put into warmer tea. Interesting analogy. Although 10 inches doesn't sound like much, that's a global average. Some coastal areas will be hit with more, and high tides and storms on top of that could be even worse. So this much sea level will have a huge societal, economic, and environmental impact, said Ellen Edelin, a geosciences professor at Boise State University. Boise.
That's another long one.
Time is the key unknown here and a bit of a problem with the study. said two outside ice scientists, Leah Stearns of the University of Kansas and Sophie Nowicki of the University of Buffalo. The researchers, yay, Buffalo! The researchers in the study said they could not estimate the timing of the committed melting, yet in the last sentence they mention within the century. I still think that's really, really conservative, honestly, without supporting it. Colgan responded that the team doesn't know how long it will take for all the doomed ice to melt, but making an educated guess, it would probably be by the end of the century or at least by 2150. I think way before that. Colgan said that this is actually all a best case scenario. You betcha, baby. It's not the worst case. They're presenting the best thing that could possibly happen.
Oh, boy.
The year 2012, and to a different degree, 2019, was a huge melt year. Huge melt year. When the equilibrium between adding and subtracting ice was most out of balance. If Earth starts to undergo more years like 2012, Greenland melt could trigger 30 inches of sea level rise, he said. Those 2 years seem extreme now, but years that look normal now would have been extreme 50 years ago. I think we're going to have so many more 2012 years, and soon. It's just been a miracle almost that it hasn't happened already, you know. That's how climate change works, Colgan said. Today's outliers become tomorrow's averages. And there you go.
Yep. There you go. And that was this was the Nature Climate Change article that everything was from.
Yeah.
And we have actually one more fantastic article, which this was Jennifer's also. It's Jennifer night. Are you up for it, Jennifer?
Why not?
Oh, she's
Why
up
not?
for it. This is great.
Why
we'll
not?
find a toilet flush, I'm sure, in this one. Earl, are you still here? We haven't done it yet. Jennifer, if you find a toilet flush worthy piece in this article, go for it. So I'm giving, methane hunters.
Right. This is
methane
the Financial Times. And let's see, this came out August 22nd, so very recently. Methane hunters. What explains the surge in the potent greenhouse gas? Levels of the gas are growing at a record rate, and natural sources like wetlands are the cause, but scientists don't know how to curb it.
Lovely.
Whoa. Every year, 6,000 flasks arrive at a laboratory in Boulder, Colorado. Inside each is a sample of air taken from one of a chain of 50 monitoring stations that spans the globe. Together, these samples could help answer one of the most important questions facing the planet. Why is there so much methane in the atmosphere? Blue and black canisters filled with air from Algeria, Alaska, China, Samoa are lined up and ready for testing. We collect these flask samples, then they come back here, said Ed Dugowski, a chemist at the Global Monitoring Laboratory run by the U.S. National Oceanic and Atmospheric Administration. The laboratory measures the different levels of gas inside the samples from carbon dioxide to nitrous oxide and sulfur hexafluoride, compiling a meticulous record that forms the basis for major climate models. About 15 years ago, its researchers observed an uptick in atmospheric methane, a potent greenhouse gas, with a warming impact 80 times greater than CO2. Many researchers initially assumed that the increase was linked to fossil fuel production. Methane is the primary ingredient in natural gas, but is also produced by other human activities such as landfills, rice paddies, and raising cattle. In the past few years, however, that uptick has accelerated into a surge.
Forgot broccoli, Jennifer.
Huh?
You forgot broccoli.
I forgot broccoli.
Yeah, as one of
I'm
the
sorry. Oh, I'm in a different world.
I know.
I'm elsewhere. I'm in the Financial Times.
You were reading it.
Don't bother me. I'm reading.
Okay. I'm putting myself on mute.
Okay. In the past few years, however, that uptick has accelerated into a surge. The implications for global warming are immense. Of the 1.1 C increase in global temperature since the pre-industrial times, about a third can be attributed to methane. Atmospheric methane had its highest growth rate ever recorded by modern instruments in 2020. And then that record was broken again in 2021. Nobody knows exactly why. It is shocking, said Lindsay Zin Lang, a researcher based in the Boulder laboratory who is analyzing the data. A lot of research, a lot of scientists are trying to explain it. Atmospheric methane reaches highest level ever recorded by modern instruments. Do you see a trend?
I
Let's
see.
take a
Holy
look
crap.
at this graph. So this probably goes from about 1983, if you kind of extrapolate down, or in
on the bottom.
85. So this is like from 85 all the way to 2022. So we're looking at, 45 years of data or something, But look at this thing. It kind of sort of evened out, or like stopped accelerating so much from 98. Remember, they used to say, the goddamn Republicans, that there was 12 years, there was no global warming. It's a plateau. But do you see this little double bumpy thing here in 98 to like 2007 about?
The
right?
double bumpy
That
thing?
was, yeah, the little bumpy thing that goes from 98 to 2000, it's hard to say exactly. But it appears, where it says appears to level off and increase begins, that was a super high El Nino. So it accelerated in 98, and then it kind of flattened out in the La Ninas, right? So there was a lot of that kind of action. So what happened was, politically speaking anyway, here in the United States, all the Republicans began jumping up and down like little boys and throwing snowballs in Congress and saying all sorts of stupid things because they're so stupid. They're so suicidal, right? They're awful. They're really awful. When you look at what they're doing, what hope do we have with these assholes, right?
We don't.
So then growth accelerates. Take a look at that. In 2020, the angle goes up. It is accelerating. So the angle of that one is very, very steep. So there we are, guys. One thing they have begun to identify is what kind of methane is culpable for the increase. Methane derived from fossil sources contains more of the carbon-13 isotope than atmospheric methane, while that produced by microbial sources such as wetlands, cattle, and landfill contains less. Since the beginning of industrial revolution, fossil fuel emissions have tilted the ratio of methane isotopes in the atmosphere towards carbon-13. But around 2007, which also was an extremely low Arctic sea ice extent, that was the first time it went so much melt in the Arctic sea ice. But around 2007, when the atmospheric methane started to climb again, that isotopic ratio went into reverse. The recent increase in methane is not coming primarily from fossil fuels, but from other sources. That suggests the planet itself could be emitting more methane, and it is not slowing down. Sandy, do you recall...
The planet itself.
Yes. Do you recall that article that we did, I don't know, maybe a year ago, but it was talking about the methane pouring out of Novaya Zemlya limestone crest, the crest that makes up the peak of Novaya Zemlya,
Yes.
the limestone formation.
We
And
had
that thing,
graphics.
yes, and that thing is emitting geologic methane. So that's a different kind of methane, but it is pouring out of
It's a
Novaya
doubleheader.
Zemlya. It's pouring out of Novaya Zemlya, which coincidentally was also the place of the largest nuclear bomb ever blown up on planet Earth. And I believe that was like in 60 or 62.
Is this a
That was
correlation?
the Tsar Bomba. No, it's not a correlation necessarily. They're two
Okay.
corresponding facts that both happened on Novaya Zemlya, the biggest nuclear bomb in the world, Tsar Bomba, right? And the fact that ginormous amounts of methane are pouring out of the crust, the kind of crop
Interesting.
of Novaya Zemlya. It's happening, something to wonder and ponder, when you wake up in terror. We are seeing very substantial change, said Duglossi. After 200 years of increasing, all of a sudden we start to see a decrease in delta carbon 13. That means something significant has happened. Determining what that something significant is requires close study of methane emitted from a variety of sources, from wetlands and shallow lakes in the tropics to melting permafrost in the Arctic, from landfills and agriculture to the fossil fuel industry, as well as chemical sinks that remove it from the atmosphere.
That's some list.
Methane is a very interesting type of greenhouse gas because it has so many kinds of sources and sinks that you have to keep track of, said Duglowski. You have to look at it like you are a detective trying to solve a criminal mystery. That's how to think of it. So these are all the different sources and sinks of methane. And sources of methane include fossil fuel, agriculture waste, biomass burning, and let's see, that thing is anthropogenic and natural flux is, but I guess they're saying
The
biomass
wildfires.
burning.
Yeah.
Right, the wildfires. And then the green ones is natural fluxes, wetlands, other natural emissions, chemical reactions in the atmosphere and sink in the soil. So all about methane, it's got a lot of moving parts. Unraveling the mystery will reveal whether or not the world might face the worst case scenario of a methane bomb. You betcha, baby. I know a little about that. A feedback loop where a warmer planet emits more of the gas naturally. It's a feedback loop, the methane feedback loop, driving temperatures up further. It's a terrifying prospect, one that scientists studying this topic tend to tiptoe around, particularly in interviews. And haven't you noticed how pussyfoot they are, right? Quote, "We have a gut feeling that the climate feedback might be happening," said Lan, "but can be difficult to separate the signals from the noise." They're trying to be so careful. Others are more direct. Quote, "If you think that fossil fuel emissions is putting the world on a slow boil, methane is a blowtorch that is cooking us today," said Durwood Zelek, president of the Institute for Governance and Sustainable Development and advocate of stricter policies to reduce methane emissions. The fear is that this self-reinforcing feedback loop, if we let the Earth warm enough to start warming itself, we are going to lose the battle. We're losing the battle, you bet. Hunting for clues. For years, methane was somewhat overlooked by the scientific community and by policymakers who tended to focus more on CO2 emissions. Part of the reason for this is because atmospheric methane appeared to be leveling off between 2000 and 2007. Remember, guys, that's just what we were talking about when all the Republicans went apeshit, started acting like bratty little boys in Congress. Now, researchers are using both isotopic measurements and satellite data to determine the origins of the surge in methane. they know that the increase is coming from microbial sources because of the shift in the carbon-13 ratio. But which microbial sources exactly? Wetlands, cattle, landfill all produce microbial methane, in which microbes break
Like a
down carbon
wheel.
and generate the greenhouse gas. To determine how much of these sources is contributing, scientists are scouring the globe for data points. Paul Palmer, an atmospheric chemist at the University of Edinburgh, compares it to a game of Cluedo, the children's detective board game. The satellite data will give you the location of the murder, said Palmer, and the isotopes will give you the weapon, the type of source. So there's another little chart here. Natural sources contribute to methane emissions. This is very, very interesting. I actually studied this for quite a so it's got intelligence in it. Do you see that, Sandy, when you drag your cursor over the various lines, what it does? It's very bizarre, right? Can you see that? So this one is interesting enough, guys. The Financial Times article link will be in the show notes, and this is actually pretty darned fascinating if you want to really understand what's making the methane.
There's methane. I mean, it comes from everywhere. The garbage dump where I live. They're burning it now. They're using the methane from the garbage to make power. It's methane, the methane of our lives. The methane of our lives. Well, I think it's
we're not
been a
done.
good show.
We're not done, Sandy. We're not even done. We're not even done. We're not even done, Sandy.
Ay. Where was I? This is a long one.
I don't know. Yes. We have to get through this.
Of course we are.
All right. Wetlands and cattle appear to be the biggest culprits, said Ewan Nisbet, professor of earth sciences at Royal Holloway, University of London. The biological sources are increasing faster, he said. The most intense growth seems to be coming from the tropics. A global increase in cattle raising and landfills is also fueling the growth in microbial emissions. In an upcoming paper, Lan and Dukowski reached similar conclusion. 85% of the increase in atmospheric methane since 2007 is due to microbial sources, and about half of that is from the tropics. Using satellite data, Palmer has zeroed in on East Africa as a source of increased emissions, such as Sud wetlands in southern Sudan. We are seeing huge methane enhancement due to wetland emissions. We've only known that since 2019, he adds. Other tropical areas with wetlands such as Southeast Asia and the Amazon are showing an increase as well. When wetlands get wetter, it leads to more methane emissions because the microbes that produce the methane have more organic matter on which to feed. The sources of methane may be natural, but a climate warmed by human activity is fueling these emissions. Climate change is expected to lead to more intense rainfall in East Africa, and these wetter, warmer wetlands will produce more methane. Other natural sources of methane, melting permafrost, wildfires, are also linked to climate change. While Palmer works with satellites, other scientists are working on the ground physically, traveling around the globe to capture methane samples in canisters to be sent to laboratories, like they're sending to Boulder. The Royal Holloway lab is filled with boxes of samples shipped from around the world on the planet. These are exciting, said Rebecca Fisher, a lecturer in atmospheric sciences at the university, gesturing to a box that has just arrived. They are flasks of air from the Halley Research Station in Antarctica. Because Antarctica has no vegetation, the air there contains very little locally produced methane, making it ideal to provide background measurements. Fisher is preparing for a trip to Finland near the other end of the globe from Antarctica to collect samples that will measure what she calls isotopic fingerprint of
That's a
wetland
cool trip.
emissions in the Arctic. By measuring not only carbon-13 isotope, but the hydrogen isotope deuterium, known as heavy hydrogen, her group and others are working to build a library of these fingerprints. We get really different signatures in the Arctic versus the tropics, Fisher says. By taking these isotopic measurements, we can see if it fits with what is in the atmosphere. As well as helping scientists piece together the current surge in methane emissions, the Arctic also gives an idea of what future emissions might look like. The region is warming 3 times faster than the rest of the planet. Permafrost itself contains around 1,500 billion tons of carbon, said Katie Walter Anthony, professor of ecology and biogeochemistry at the University of Alaska Fairbanks. As permafrost thaws, that carbon can be turned into methane by microorganisms known as methanogens. Oh my God.
Methanogens.
It's
Say
the
that 10 times.
methanogens.
Ooh, it sounds like a new television show. A new show on
Microorganisms known
Netflix.
as methanogens.
Oh my God.
Oh my God. She has flown all over Alaska to measure the methane coming out of lakes, and what she has seen recently has surprised her. Quote, in the first 5 to 6 years, I have just seen incredible change, she says. It seems like we crossed a threshold and we are seeing crazy things happening. So there's another big chart that tells you more about methane, but I'm not going to go into it. But this is such a good article. I hope everybody can take time to click on it. Just go to the show notes and click on it. You'll be surprised how good of an article this is. One of those crazy things is that lakes are forming, a lot of them. As permafrost melts, these pools known as thermokarst lakes are spreading rapidly.
Yeah, we've talked about thermokarst. Mm-hmm.
Sure have. And the microbes that produce methane thrive on all the newly thawed organic material at the bottom of these new lakes. In interior Alaska, we've seen nearly 40% increase in lake area since the 1980s of these new thermokarst lakes forming. Holy cow, 40% increase in lake area. Look at that. That's the inside
not
of
in
Alaska.
Las Vegas, not out in the west.
No.
Oh my God.
No. Those lakes emit methane at least 10 times higher than a normal lake.
Ooh,
they are hot spots. Anthony says hot. Anthony says current climate models greatly underestimate the methane released by these lakes. In a 2018 research paper in Nature Communication, she calculated that the methane could become a dominant source of atmospheric warming from permafrost gases this century, between 2050 and 2070, if our greenhouse gas emissions continue on current trends. Oh dear. For now, the methane emissions from those lakes are much lower from wetlands in the tropics. We are watching the Arctic, but at the moment, the Arctic does not appear to be leading the problem, said Nesbitt. There are a lot of potential feedbacks here. In the Arctic, we need to keep watching that. Cutting the gas. While there is little that governments can do about methane bubbling out of wetlands and thermokarst lakes, they have already promised to reduce the amount of produced from human-caused sources. Around half of the methane emissions come from anthropogenic sources and half from natural sources.
You're going to kill me. You're going to kill me. You're going to kill me.
What?
You have to let me do this. Wait a minute. Everybody needs a little... Okay. I had to do it. Sorry, guys, but I got the goddamn sound, and I was waiting for an article that talked about gas. So Jennifer had to take that one. All right, there we go.
Righto. Let me have a little sip of coffee.
I got her on that one, but we all know we all partake in that one. Sorry.
No worries. All right.
Okay.
More than 100 countries signed up to the Global Methane Pledge, launched at the COP26 Climate Summit last year, pledging to collectively cut methane emissions 30% by the end of this decade. Cutting methane emissions would have a more immediate impact on temperatures within a human lifetime than cutting CO2. That's true, because methane is so quick and it responds so quick, and its lifetime is nothing compared to carbon dioxide. That's because methane only lasts a decade in the atmosphere, depending on conditions, compared to the century or more CO2 remains there, right? A concerted global effort to reduce methane emissions using existing technologies could slash anthropogenic emissions by 45% by 2030, according to a May 2021 report from the UN Environment Program, avoiding a 0.3 C of warming by the 2040s. The quickest methane fixes are the fossil fuel sector, which accounts for about 1/3 of anthropogenic emissions. Special venting installed in coal mines, early detection of gas leaks, reducing methane venting during oil and gas production, and other readily available measures could cut methane emissions by more than 40 million tons this year, according to the report. Capturing natural gas from landfills would even pay for itself because of its resale value.
Which is what they do here where I live. I took the tour. I took the tour. It's quite a thing. Yeah.
Wow. Cool. Still, it's not clear this will be enough. The world's biggest methane emitters, China and Russia, have not signed the COP26 pledge. And even if they did, it's not clear that reductions in human-caused methane will be enough to compensate for the increase from natural sources. If the warming of Earth is already starting to release more methane, then its vicious cycle in which warming triggers more warming could become self-perpetuating. Although that moment could still be decades in the future. Once that tipping point is reached, it will be very hard to reverse.
Yeah.
AKA impossible. Anticipating this, some groups are starting to study methane removal, whether there might be ways to pull methane directly from the air. While most hypothetical at this point, the ideas include increasing the amount of chemical sinks in the atmosphere, for example, by adding tiny iron oxide particles into the air. Other approaches include using methane-eating bacteria to act as a filter for methane, such as at dairy farms. I've heard a lot about that methane-eating bacteria. Yet, even as methane rises in priority, funding to monitor it has not kept pace. There really hasn't been big expansion in our network for the last 15 to 20 years, said Dukonski. Federal funding cuts a decade ago mean the network today is smaller than it used to be. Still, the methane hunters keep going. Right now, we are trying to work out the source signatures. We need to get a global database, said Nisbet. He has recently returned from a trip to Canada where he was collecting swamp samples. Though Nisbet is nearing retirement, he keeps going out into the field searching for the answer to the riddle. Our level of primary knowledge is still very, very low, he says. Methane keeps kicking up these surprises.
Yeah, methane, the gift that keeps on giving. keeps on giving. It keeps on giving. Well, thank you for being the narrator for most of the night.
Oh, my pleasure. Happy to.
I thought that was
happy to
quite good for my my throat. Definitely. Yes.
Yeah.
All right. Well, I think it's been an interesting show. I hope you guys liked the videos and the information. We didn't get a toilet flush in yet, so I think we're gonna have to out there. Is there anything that anybody could quickly think of that we went over that deserves the environmental coffee house flush of the day? I mean, I have an idea of what I would like to flush. But I'm asking you, yes, I'd like to flush. All right, I'm going to go. I'm going to flush. I would like to flush problems in my chat away. I would like everybody to get along because we're all here to learn and we're not here to fight. So I'm going to flush any of that away. It's going. Thank you very much for letting me flush that away. I want everybody to get along. That's all. I it's just, and thank you. And I know Sat 12 is difficult, and Sat 12 needs to make a decision whether he wants to come here or not.
Oh, I see. That
and
guy.
keep his mouth shut. Yeah, that's all. There's been it's been a weird night in the chat, but you know what? I love you all. And I want to thank you very much, everyone, for coming and letting Jennifer, allowing us into your living rooms and enjoying our choices of articles and our videos. And, we're all together in this. And if somebody thinks that there's a techno fix and that there's a future, I'm happy for you. I am. And but we are obviously not the place, because we're not going to tell you to, that all is lost, not to live your life, not to do your thing, not to go to school like Dwayne does, not like Nick getting his PhD, like Jennifer in her career, like me learning filmmaking and doing a homestead. I mean, there's so much to do. No one ever says not to. We just bring you the truth. We bring you the mainstream and not so mainstream. And if the mainstream media is talking about it, you better fucking be sure and realize that there's something behind it percolating. That's all. All right, Jen, take it away.
Indeed.
You give up
the
final parting gift.
This tonight has been a topic that's near and dear to my heart. I have been researching this topic for a long time, and they did mention in 2012 that a huge melt set in, and that actually was the lowest Arctic sea ice extent. That also was the year that I flew over Greenland in the end of August, at the end of the London Olympics, going back to Denver.
Changed your life.
And I saw for myself, it did, it changed everything. And it shocked me and it riveted me. And I saw for myself how that whole giant island of ice is just melting down. It's filthy, it's rivulets, it's Swiss cheese, it's full of lakes and dirt, and it's very sad. But that thing really did change my life, and I went on to study a lot of methane after that. So, it's a fascinating time. Anybody here who has a scientific bent to your mind, dive in if you haven't already, and I'm sure you'll learn more than you counted on. It's a fascinating time to be alive. It's a scary time to be alive. It's a profound time to be alive. And I'm happy you're all here. So that's it, Sandy. That's it.
Yeah, we are. Thank you very much, everyone. We love you, and we'll see you next Tuesday. And I will be putting the I don't know when, with the way my life is, when my show will be. If it'll be Friday or Sunday, you'll know. All right? You will know. Good night, everybody. All right, here we go.